Good morning. This is KAP for Tuesday, the 11th. Our warm-up is, we have a graph. Sorry, you can see it. We have this graph, and we want to know what the next coordinate, what is the next coordinate when the number pattern is continued? What do you think, Abe? 4, 2. Do y'all agree? Yes, okay. How much is it increasing each time? 0.5. It's increasing 5.5. Something that's helpful sometimes, I don't always like do the graph because they don't have the numbers, I either like to write the ordered pairs next to it, or I like to make a table right next to it. That way I don't have to find the coordinates every single time. So it was 1, 1/2, 2, 1, 3, 1 1/2, and then 4, 2. Okay, I agree with this. Let's review what we talked about yesterday. Is it additive? Is it multiplicative? What do we think? Okay, I'm hearing mix of both. So let's ask ourselves, what's happening to x to get to y? What's happening each time? Maria, what's happening each time?
It adds.
It's adding half to the y values, but again, we want an input-output. How is it going from 1 to 1/2? How is it going from 2 to 1? Heyman.
It's divided by 2.
Divided by 2. Do y'all agree with that statement?
Yeah.
Okay, every single time they're taking x and they're dividing it by 2, and that's how we get our y value. Do y'all agree with that? Okay, I agree with that as well. So would that be an additive or multiplicative? Multiplicative. Even though it's division, it is multiplicative. How could I write that as a multiplication problem? Still having, yeah. Very good. Okay, you could do 1/2 times x, or you could do 0.5 times x, and that's how we get our y value. That is exactly correct. Okay, and therefore it is multiplicative. Do y'all remember another way I can easily tell just by looking at the graph to see if it's multiplicative? We talked about it, Will. It lines up with the origin. If I were to extend do the connect the dots game, if Miss Little is perfect, it goes right through that origin, and that will always have to be multiplicative. Y'all good with that? I did make that line, but I used my line tool to help me make that line. Oh, okay. Homework questions. Yes, sir.
Number 6, the first one, it says that on the key, it says that multiplicative, but shouldn't it be additive?
So let's look at it. That was the one that we as teachers even talked about. We were like, Okay, number 6 says the number of apps increases by 1,500 each month. Okay, so let's discuss why that's multiplicative. I like to go back to that table like I did on the warm-up. Okay, I like to make a table to just put some numbers with it, x and y. X is going to be talking about my number of months, right? And therefore my y is going to be my, what are we talking about in this problem?
Number
The number of apps increased by 1,500 each month. So if I had 1 month, this output is going to be 1,500. And 1,500 is talking about what? It's talking about x. Y is talking about my apps. I literally cannot write today. Okay, so let's just pretend if I had 2 months, how many apps would I have? How many? 3,000. If I had 4, yeah, sure, let's go 4. What would it be? How much? It would be 6,000. So you sort of have to ask yourself, what relationship do you see? What do you see happening each time to go from x to y? Yes. Amen?
Wouldn't like a 3 be 6,000?
No, 3 would be 4,500.
So that one was
well, it's a little tricky because I think the word increase throws a lot of people off. Okay, but let's look at this chart. Is my amount still increasing by 1,500 each month? Okay, they are adding 1,500, but they're adding from y to y. Okay, but each is a keyword for what operation? Multiplication. So if I ever get confused, I just like to make a table that goes along with it, and then I'm like, oh, obviously that's going to be a multiplication because I'm not adding this way. I'm not adding 1,500. I'm adding to the y values. Okay, so the input output is a multiplicative relationship. That was the one that I was like, well, if you just read for the words, yes, it's tricky. Okay, we're gonna go ahead and hop into the notes, I think, since we're good. So again, just talking a little bit more about additive and multiplicative, some key words, what it looks like in all the versions. Okay, multiplicative, the root word in multiplicative would be multiply, probably. Multiply is going to be sort of our root word. Okay, so we are going to have a paired equation. It's just like sort of a, what's the word for it? Standard format. Like you can replace it. You'll see what I mean. So in a paired equation for a multiplicative, it's always going to be my output is equal to my input times a number. Y is equal to AX. Again, A is whatever I'm multiplying by in that equation. My X is my input, my Y is my output. Okay? We also have times where we do like a fraction, so it might also look like 1 over AX is equal to Y. That's when we do like 1/2 of X or 1/3 of X, and we'll get used to that. Again, it's a parent function because, or a parent equation because we can change out that A for a bunch of different letters as we go through different equations. Some keywords for multiplication. We just said one of those words is for each, like per, for every student. We get 6. You can say like half of something, a third of something, a fourth, fraction go on forever. You can say like, 20 groups of 4,000, and then you multiply those pieces. Okay? Those are all multiplication type words. For additive, the root word is wow. Okay? In my parent equation, I'm going to have my output is equal to, it doesn't matter what order you put it, but I'm going to put X plus A, where you have your input and you're adding something to it. Okay? Again, sort of like with this is sort of a multiplication and division way. You can say Y is equal to like a negative A plus X, and that's how you sort of work subtraction into it. Okay, words that mean additive, this many more than someone else, if you want to plus or add. Also, since we can include subtraction in there, we can say we lost something, we gave away, all that jazz. Take away. Okay. Again, this seems like it's harder. It looks like it's harder than it actually is. It's nothing too clear. Yeah. Okay, and then we're going to go into some stuff that we just talked about yesterday, but we're just solidifying that information. Sometimes in math, we use a symbol, usually a letter, to represent an unknown number. That letter, did y'all hear me call it something? Whenever we have a letter, it's called a variable. Very good. Because it varies as we go. It's a variable.
What does it mean by variable?
Like it changes. Because my variable, again, my X, my input could be 1, it could be 2, it could be 3. All right? So we use variables and rules using variables can be written to describe the relationship between each input and output. As we said yesterday, our input is always our X value. And let's take this over to science class. Have y'all talked about like the graphs? Okay, like on the first quadrant of your graph, and you have your experiments, and there's the one that you control, and then there's the thing that changes, and they're called different kinds of variables. What are those two different variables? I don't have independent and dependent. The independent, if you're an independent person, you're on your own, you control yourself. Okay, if you're dependent, as children, y'all are called dependents because you rely on your parents. Okay, because they pay for you to do stuff. Okay, Miss Idle has a job, so she's independent. Y'all rely on your parent because y'all are at school and can't work right now. Okay, so your input value is your input. I always think of input is your independent, independent quantity. The I for input, independent, that's how I remember it. And then your output, whatever comes out of the machine, relies on what you put into it, okay? Your Y is your dependent quantity. Dependent. How far your race car goes depends on how high you set the track. Those are sort of things.
Or the batteries.
Or the battery. It depends on that kind of stuff. Okay? And then I always like to think of my rule is what are you doing to X to get Y? What are you doing? What are you doing to X in order to get Y? I'll pause and play. So we're just going to practice that value. So we said X is our input, and that therefore it's my which quantity? It's my independent. Very good. So let's try that one more time. My X is my input, therefore it's my independent because I'm controlling what it is. The Y is going to depend on that input. Means independent. All right. In this problem, it says 6x. 6x means what operation? Multiplication. Very good. It's going to be weird, and we have to get used to it. When there's no symbol, it's just the letter, the number and the variable. When it's just them next to each other, we're going to multiply. So I'm going to show that I'm going to multiply. I'm going to be replacing x with each of these input values. So remember when I write, when I fill it in, again, I'm replacing x with a number. I have to put it in parentheses to show that they're separate things. If I just write 6 and 0, it looks like 60, which is not the case. I'm going to get away from using the multiplication symbol, and I'm just going to write them next to each other. For this one, x is now going to become 1. Then it's going to be 6 times 2, 6 times 3, and 6 times 4. And we just solve those now. 6 times 0 is?
0.
6 times 1?
6.
6 times 2?
12.
Go on. And then we're going to make that into coordinates. Okay, the first coordinate, the first ordered pair is going to be what, comma, what? Ooh, let's try that one more time. 0, comma, 0. Okay, because I put in a 0 and I got out a 0. I put in a 1, I got out a, fill in the rest. Okay. Does this follow that multiplicative rule of going through the origin? Of course it does, Miss Idle. Yeah. Okay. Again, here my process in this case is going to be what kind of number relationship? Additive. Okay, so I'm just replacing x with that number. 0 plus 8. 0 plus. Oh no. I should be 1 plus. You'll know what to do. Go ahead.
No.
You do know what to do. Yes, yes, yes. 1. Same. Great. Now we're gonna graph. Here we go. So let's put some stuff on this graph. It's missing like everything to it. Let's put some numbers. What's gonna be right here? 0. Okay. Whenever we have to number our graphs on our own, I'm again pretty sure y'all have practiced this. Just make sure it covers the range that you have. So on my x's, I need to be able to cover from 0 to 4. So could I spread these out probably? Yeah. Let's see if I can do every other. Let's do 1, 2, 3, 4. Great. Love that. You don't always have to make it so scrunched up. Give yourself some space. Okay, on my y-axis, I need to make sure I go from what to what, at least. If I'm graphing this, what do I need to make sure?
24.
I need to go up by, up to 24. So what do y'all think Can I do 1, 2, 3, 4? Ooh, no. Ooh. I don't want to be basic and go by 2s. I want to go by 3s. Because we can do that. We're big kids now. Ugh. Okay? So if this is 0, let's do 3, 6, 9. Oh, I wouldn't even be able to fit if I did it by 2s. Bam.
I made it.
Well, if you extend it on, I don't know. So many people just get scared of their sleep. Like, oh. You're strong, independent. We're independent, dependent. 6th graders. We don't need no 2. All right, and then we can graph it. Okay, graph those points right here. Write them out. If I beat you, you're going too slow. Correct. Once you finish, go ahead and do that additive graph as well. Okay, on this next one, do I need to count by 3s or can I spread it out a little bit? I can spread it out. I probably 2, 4, 6. Oh, I can't do it by every other. What did they do? What did they do on this one? Oh, they did. What? They
You
did.
can also do by 2.
I can do by 2, 4, 6, 8. 0 and 8. 9. Oh, 9. 10. 11. All right, very good. Let's go ahead and put some labels on this. So this horizontal axis is called my. This one is my which axis? This is my x. This is my y. If I put the variables with it, which one? The horizontal, is it dependent or independent? Independent, because it's my input value. It's my independent value. Okay. ND 10 Okay, and therefore this is my dependent. Dependent is usually the one that you're looking at because that's where like your results are coming from. You know what I mean? Okay. What do y'all notice about these graphs? Hopefully we caught on to it. What have Miss Lytle been pointing out about the graphs? They're both linear, very good. Will, what's that thing that you pointed out earlier? On which one? Is that holding up? Is that multiplicative through the origin?
Yes.
Yeah, is that additive not through the origin? Very good, awesome. Okay, so now we're gonna sort of spice it up. Nothing too crazy still, but sometimes we have to work backwards. Sometimes we're given our output, sometimes we're given our y, and you need to figure out what they put into the machine in the first place. Okay, we can still do it. You just need to figure it out. So if my rule was x minus 2, and I got 9 on the output, what do you think I put in the first place? 11. So let's try that out. If I put in 11, is 11 minus 2 9? Yeah. Okay, what do you think I had to put in for 11 to come out? 13. 13 minus 2 is 11. Great. And lastly, 15 minus 2 gives me 13. Okay? So, like, what's another way I could think about this? Instead of, like, what did I put in? How could I maybe work this in a different way? Yeah, Ava, what do you see? I could, like, work it in reverse. I don't know. Okay? Instead of subtracting 2, I do the opposite. Because I go the opposite way, I do the opposite operation. Okay? So that's going to be important. If you need to, if you just need to process that, we'll get into that a little bit more, but I do want you to start realizing if I'm getting my output, I work backwards. I'm going to do the opposite operation. Okay? Great. Number 2. Ooh, what operation is this, class? Multiplication. So maybe think, what times 8 gives me 16? What times 8 gives me 16? 2. 8 times 2, does that work? Great. What times 8 gives me 24? 3. Okay, y'all see how we're just sort of changing what we're thinking? And what gives me 32? 4. 8 times 4 gives me 32. Juicy. So thinking sort of similar to Ava, in this case, how else could I think about that? Payment. You're divided by 8. Okay? Because you're sort of saying 8 times x gives me 16. I want to divide. I'm going to divide by 8. I'm going to divide by 8. X equals 2. Okay? Of course, we can do some word problems. I would never not give you word problems. A pizza place sells pizza for $7 each pizza plus a delivery charge per order. If Pat orders 3 pizzas to be delivered, what will be his total cost? Look for some keywords in there, underline. Okay, some keywords Maria pointed out. Each, per, both of those mean multiply. What's another keyword in there? A plus. What does plus mean? Plus. Okay, these mean time and plus. What I do want to point out to this, so you're ordering a pizza, and okay, pretend it's Friday night, you're having some friends over, your mom calls up the pizza place, and they're ordering pizza. Okay, we know that there's like the $7 for each pizza plus the delivery charge. Are they going to charge that delivery charge more than one time?
Yeah.
Do you think the pizza place, do you think Domino's is going to be like, oh, here's the first pizza that you ordered, they're going to drive all the way back, and they're going to drive all the way back, and they're going to be like, here's the second pizza, and they do that like 20 times? No. No, okay? So you have to keep in mind that this per, yes, that means multiplication, but per order, how many times are you actually going to pay that $4? Once, because the order is all of the pizza, okay? So we're only really going to be multiplying times the 7, okay, and then adding the 4 onto that. So what that looks like, so $7 each pizza for, and they're ordering 3 pizzas. So we need to do 7 times 3. Do we agree with that? What else do we need to pay for? Plus 4 to give me that money. Okay? If we're looking for like the rule, okay, I'm going to say it's 7 times however many pizzas. So I'm going to put P for pizza plus that 4, and that's going to give me C for my cost. That's going to be my total amount. Okay? Do y'all agree with that equation I just wrote? I'm going to do 7 times the number of pizzas plus that P is only going to happen 1 time. Okay? What are we going to solve first? Add or multiply first? Multiply, that's going to give me 21 plus 4 is equal to 25. My cost is $25. Okay, I think I'm going to do one more and then I think y'all are good to go. Okay. The Adams family is traveling at a rate of 70 miles per hour. The rule that represents the situation is 70x, where x is the number of hours. Make a table to find out how many hours they have driven at 140, 280, and 350 miles. Then graph those ordered pairs. Okay, so some keywords in there. It gives us the rule, but what was another keyword that tells me that rule? Per hour. Okay, 70 miles per hour. That's a hint that you're going to be multiplying. Okay, but it does give us our rule. It's going to be 70x. Our x is talking about what units? X is talking about hours. And what's going to depend on that is the number of miles that I have driven. Okay, that makes sense. Hours depend, or miles depends on the number of hours. Okay, it wants to know, like this table is not filled in, but they did give us information. They say 140, 280, and 350 miles. Are those going to be my input values or my output values? Output. Why do y'all say output? Because miles. It gives you the units you need to pay attention. So we're going to fill in 140, 280, and 350. So again, it's that working back. what times 70 gives me 140? Or you can think of it like Heyman said, what operation could we sort of do to help us figure this out? You end up dividing, okay? So what times 70 gives me 140? 2. What times 70 gives me 280? 4, and then 350? 5. Okay, and again, it's always good to check and just practice writing it as well because it's new. It's exciting. Okay, that ordered pair, it's going to be my X, comma, my Y. They always go together. Okay, let's add some units to our graph. On my x-axis, it's talking about what units?
Input.
It's my input, which is hours. Again, I have it labeled over here. That's fine. My dependent value is my miles. Okay, and then go ahead, graph. Right there now. Okay, let's look at this. I don't know. My keyboard is a little funky, so let's look at it. Okay, 2, 140, 2. Okay, I'm sort of connecting these. Help me out. Not a pretty graph. 2, 140. If 50, if it's every other is 50, then halfway your speed would be 25. Okay, just checking. So 2, 140. If I added, okay, so if this is 2, halfway between 100 and 150 would be 125, so it needs to be a little bit above that. Yeah. 4, 280, so I'm going to go to 250, and then I'm going to go a little bit. Is it going to be before or after this middle line? After, because that middle line would be 275, so it's just going to be just above. We're pretending this little thing above, or not so smart for it. And then 350. Oh, above the graph. Well, this graph is not a pretty graph. Let's pretend, yeah? Okay, ideally that would be linear. I'm just going with the flow for that. Sorry, it's a not perfect graph. We'll remake it. Okay, are we understanding additive versus multiplicative? Yes, Miss Lytle. Great, awesome. With the partner, do the odds. Make sure you cross out this envelope here. Ready, set, math. We'll check it in a second. We're doing the odds only. At home, you can just check it on camera.